Hey physics friends, I want to talk to you today about the worksheet sine, cosine, tangent, law of sines, law of cosines, practice number 2. I'm going to be going through the first 3 questions today, so question 1, question 2, question 3. I think I may save the next 3 questions just because these get a little bit long as I'm explaining them. So let's get started. Number 1 is a person decides to row a boat across a river. The river is running east and west. So what I'm going to draw a river. It's running east and west. The current is running at 15 meters per second. So the current is 15 meters per second. The boat, they point their boat speed. So we're going to go boat. We point their boat going directly north at 8 meters per second. If a person was directly above them, as we are from this point of view that I draw on it, what specific direction do they see them going as they row? Okay, so this is a vector problem. So you've got a boat trying to go across the river and the river blowing them downstream. And I actually have a simulator for this to kind of give you an idea of what this actually looks like. Let's see here. The one says boat. Oh, this is not the one I wanted to do. It works, but let's try this one. This one's a little bit better. Oh yeah, this is the one I want to show you. So here I can adjust the river speed, and I can look at the boat speed. I can't go any lower than 9. Let's see. Oh, there's 8. And I think this thing only goes up to 10. So just to kind of give you an idea of what this is going to look like, you get blown downstream, right? So you could lower the river speed, and you can see that you get blown less downstream. If you want to, you can counteract the river by pointing yourself upstream to try to make yourself go kind of straight across. I can maybe point myself a little more upstream, and I can increase my velocity. See if that helps. Well, there we go. Now I can actually make headway. But that's kind of the idea here. We've got competing velocities. So this blows me downstream, so I end up traveling in this direction. My resultant, we'll call it R. You're going to use the Pythagorean theorem to find that. So it's R is going to be equal to 8 squared plus 15 squared. So my resultant, doing that math, turns out to be 17 meters per second. So that's part A. Part B says, what speed does the... Oh, wait a second. Oh, whoop, I take that back. That's part B. Okay, it wants to know what specific speed. Part A wants to know what angle. So I need to know this angle. So this will be part B. And then part A, I'll use my favorite trigonometric function, tangent. So inverse tangent of the opposite divided by the adjacent. That turns out to be 62 degrees. So, and since this direction is north, we're going to be measuring east of north of that 62 degrees. From the way I did it. Part C, it says the river is 100 meters wide. So this river here is 100 meters wide. And it wants to know how long does it take for them to cross the boat to get across. All right, this gets a little tricky. What I'm going to do, I'm going to make a similar triangle. So I'm going to make this triangle, and this triangle right here. And when I bring this over here, these two pieces, I know that the river is 100 meters wide. And I also know that the angle right here is 62 degrees. So what I'm going to actually find is the distance that they travel. This R represents the velocity that they travel, and then this letter D is going to represent the distance that they actually travel. They're not going 100 meters. They're actually going to go this distance right there to cross the river. So let's see what I will use cosine. I'm going to say the cosine of 62 degrees is equal to the adjacent 100 divided by the hypotenuse, letter D. So I'm going to take 100 divided by the cosine of 62. So that distance right there turns out to be 213 meters. So using this equation, velocity is equal to distance divided by time. My velocity across the river at the direction I'm going is 17. The distance that I'm traveling, this distance right here that I travel across the river is 213 meters divided by how much time it takes. So I'm going to take 213 divided by 17 to find my time, and my time turns out to be 13 seconds. In number 2, you've got a drone, and it's flying a bunch of different directions. So we're going to try to make it as close to scale as we can. So when we're doing this, so it goes 45 miles north. So this is going to be 45 miles north. Uh, 30 miles west, so I want to make this a little bit less than 45. 20 miles south, so then I'm going to go a little bit less than halfway. And then 50 miles east, so when I go east, I go 30 plus another 20. And then I go 15 miles south. So another 15 miles is going to put me probably around here. So I tried my best to like keep it to scale. How far and in what specific direction must the drone fly to get home? So you want to know, how do you go from here to there? What we're going to do in this case, this is going to be one of those where we follow the 4 protocols, where step number 1, you add up, you look for any diagonal vectors. Step number 2, you add up all the x's and y's. Step 3, Pythagorean theorem. And then step 4 is the inverse sine, inverse cosine. So here are those steps. In step number 1, look for diagonal vectors. And we go back to here. There are none. Everything is straight up and down. Everything is straight left and right. If one of these were diagonal, then you would break it into its x and y components, and then using sine and cosine. Step 2, add up all the x components and the y components. That's what we're going to do next. So I'm going to use a little fancy notation. So I'm going to add up all the displacements in the x direction. So in the x direction, again, I'm going to say that up is positive and to the right is positive when I do all of this. In the x direction, I've got a positive 50 right here. And I've got a negative 30 right there. So that's going to equal positive 20. I'm going to add up all the displacements in the y direction next. So in the y direction, I've got a positive 45. And I've got a negative 20 and a negative 15. So that equals 5. No, let's see here. 45, that's 10. Positive 10. So what this is saying is this. After this drone did all of this flying, in reality, all it did was it, in the x direction, it traveled 20 miles, and in the y direction it traveled 10. So when we want to go home, if you want to travel home, you need this. So here we are at step 3. Use the Pythagorean theorem to find our resultant. So we're going to go a squared plus b squared equals c squared, which is our resultant displacement here. So 10 squared plus 20 squared, take the square root of that, and then you end up with 22. So this is 22. How far 22 miles. And then in what direction? Here we are to step 4. Use inverse sine, cosine, and tangent. So I'm going to find this angle right here because my drone is here and it's trying to get to where it started. You want to go home. So I'm going to find that angle. And so I'll use my favorite trigonometric function, which is tangent. I may have never told you why I like tangent because it uses the original numbers. Because this 22, I ended up rounding it because of significant figures. So I like using 20 and 10, my original numbers, because it gives me a more precise answer when I actually crunch to find this angle. And that turns out to be 63 degrees. So this is going to be 63 degrees, and this direction is south, so it's going to be west of south. 63 degrees west of south. Question number 3. It says an airplane throttles up to 100 kilometers per hour. That's weird. Get rid of that. And points itself at 20 degrees south of west. So here is north, and I'm going to throttle up to 100 kilometers an hour. At an angle of 20 degrees south of west. The wind is blowing exactly 90 degrees from the plane's left-hand side. So here's the wind at 45. So I actually made that a little bit too long. So 45. What specific direction does the plane actually travel? What speed does it travel at? How long will it take the plane to travel 200 kilometers? So here we go. This one's going to be, we're going to follow these same steps again, except now in the last problem that there were nothing that was diagonal. Now in this problem, everything is diagonal. So look for diagonal vectors. That's going to be everything. So here's a diagonal vector. Here's a diagonal vector. And we're going to break it into their x and their y components. Some people will sometimes ask me, Mr. Hare, how do I make my triangle? And the answer is, it doesn't matter to a point. I could have just as easily made my triangle like this. As long as you have a right angle between your x and your y, it doesn't matter how you decide to make your triangles. I could have just done it. I could have easily done this like this, but that gets kind of jumbled. So my x and my y. Oh boy, no, I can't get out of that. Okay, now let's see what we can do here. We know that this angle is 20 degrees. And then this one right here, this is 90. So I believe that this is also 20 degrees from that. So using sine and cosine, I'm going to skip over doing the math to show you all of that stuff. But the y here is 34. This x for this one is 94. For that smaller one, the x is 15, and the y is 43. Okay, so I've got my parts. Next thing I'm going to do, I broke them into my x and y. Check. Now I'm going to replace them. So in this problem, I'm going to replace this vector right here with its x and y components. So 34 and 94. And then I'm going to replace this one with its x and y components. So its x component, 15, and its y component, 43. So now I can figure out, I'm going to add up all the x components and I'm going to add up all the y components. So that's going to be my next one. Add up all the x, add up all the y. So I'm going to add up all the velocities in the x direction. These are velocities now. I've got a negative 94 because it's pointing to the left at 94, and I've got a negative 15. That's also going to the left at 15. So negative 94 minus 15 turns out to be negative 109. I'm going to add up all my velocities in the y direction. So in the y, I've got a negative 34 because it's going down south, and I've got a positive 43. So that equals 9. So when all is said and done, in the x direction, I'm going this way at 109, and I'm going this way in the y direction at 9. This is the resultant x and the resultant y directions. I'm going to now use the Pythagorean theorem to find my resultant. So I'll go 109 squared plus 9 squared, and I'll get my resultant, which turns out to be, with significant figures, 109 kilometers per hour. Part B says, wait a second, darn it, I did that again, where I found part B first, and part A says what specific direction. So I'm going to use this direction, find my direction here, and my direction is going to be the inverse tangent of opposite over adjacent. And that's going to be a pretty small angle, is my guess. 4.7 degrees. So 4.7 degrees. And then this direction right here is west. So north of west. And then part C, how long will it take the plane to travel 200 kilometers? I'm going to go velocity is equal to distance over time. My velocity is 109. My distance is 200. And figure out how much time. So I take 200 divided by 109, and I end up with 1.8 hours. So there I am, kind of taking my way. I'm going pretty slow, and I'm going pretty methodically through each of these 4 things. It's nice that I've got a smartboard. I'm able to move things around. It would be helpful if you had colored pencils. Take up lots of room. Some of the biggest mistakes I see with students is that they really try to cram things into small areas. These trees died for your education. Honor them. I use like a half a sheet of paper per problem when I'm doing something like this. Good luck, kids, and we'll talk to you later.